Hello.
Hi, Gennaro. Welcome.
Hi. Oh, when we take our exam, like, do you want us to see our computer screen too, or?
No, I can ask you to share your screen, but I don't think I'm going to do that.
Yeah.
All I'm going to be asking you to do is have your phone pointed at your desktop. And so the reason for that is I just want to ensure students are not using calculators and also not getting any outside assistance.
Yeah.
So you won't have to share your screen.
Okay.
All right, folks, let me share my screen and we can get started. All right. Folks, let me bring up the calendar and we'll get started in just a minute.
Like, so far, it's only like a paper and pencil test then.
No, Gennaro, the final exam
Yeah.
is going to be taken online in WebAssign.
Yeah.
So it's not going to be paper and pencil. Initially, we were planning to have a paper and pencil test, but then with the announcement that we're not meeting face-to-face anymore,
Yeah.
we can't do a paper and pencil test. So you're going to be taking the test in WebAssign. Let me log into WebAssign, Gennaro, and I'll show that to you. Hang on one second.
Okay.
So Gennaro, let me point this out in a few minutes. I just want to give a few other students a chance to join us, and then we can get started. All right, folks, why don't we get started then? Thanks for joining. All right, folks, we've come to the finish line today. Notice May 1st is our last day of the course. So this is our final class meeting. We're going to finish up our review of the final exam, okay? I want to just mention the items that are left to finish up the course. So let me go to WebAssign.
Okay, he's being silly as shit.
Gennaro had a question about how do you take the final exam? Well, when you go into WebAssign, notice right here is a link. It says MATH026 final exam. So, Gennaro, our final exam is Monday at 10 a.m.
Okay.
So on Monday at 10 a.m.,
Mhm.
you're going to log into WebAssign, and you're going to click on this link to take the final exam. Okay?
Oh, okay.
It's going to be taken in WebAssign. Now, there is a password on it, but I'm going to give you the password on Monday at 10 a.m.
Like, will you email it to me or?
No, you're going to be joining
Okay.
a Zoom meeting at 10 a.m., just like you're doing now.
Yep.
And during the Zoom meeting, I'm going to tell you verbally what is the password.
Okay.
Right? So that's going to prevent students from joining early and taking the final exam early, right? Because you won't be able to start it until May 4th at 10 a.m. Okay? Now, folks, I wanted to mention that all of these homeworks that you see here are open until May 1st. So the Chapter 9, Chapter 10 homework's open until May 1st. There is the test on Chapter 10 that's due May 3rd. That's Sunday. And there is this homework 10-8 also due May 3rd. So let me go to an announcement. I just sent out an email today about this. So here are the due dates. Homeworks and tests are due by May 1st. But the Section 10.8 and Chapter 10 tests are due by May 3rd. All right, so you have a little extra time for the 10-8 homework and the Chapter 10 test. Okay? Folks, also, let me remind you that when you go to take the final exam on Monday, please remember that you can use this reference information. Right, so you can either print this out or have it up on your screen.
I already have it printed already.
That's good. Yep, printing it out. That's
It's about like 8 pages.
Yeah, that's what I would do. I would print this out myself, but you can either print it or use it on the screen. It's got the unit circle. It's got all the formulas from Chapter 9, Chapter 10. So you can use this during the final exam. Remember, you cannot use a calculator.
But we can use this then.
But we can use this you can use this reference sheet. Yes.
All the formulas.
You have all these formulas available to you. Yeah. And folks, here's another handout just reminding you about all the details for the final exam, okay? And this is posted in Canvas under the final exam section of modules, okay? So if I go to modules here in Canvas, I scroll all the way down. Here's the file on the background information for the final exam. Here's the practice final exam that we're going to go over now. Here's the reference information for the final exam that you can use on Monday when you take the final exam. All right, folks, any questions on due dates or what's coming up over the next few days? All right, folks, why don't we then go to the practice final and let's pick up where we left off. And I think we were, I think we had gotten to problem 17, right? We're going to do problem 17. All right, let me get the reference information up side by side so we can use this as well for help. Okay. We might need the unit circle, so we'll keep the unit circle here as well. All right, let's go to this problem 17. It says, find all solutions to this trig equation. And you can see the trig equation here is secant x minus sine x minus 2 sine x equals 0. All right, well, some of these trig equations could be solved using kind of methods from algebra. Let me remind you of just a simple trig equation. What if I had an equation that said sine x equals 1/2, let's say?
That's, I mean, we have to know what secant is. We have to get.
Yeah, I'm doing a separate example, Janara. Let me just do a separate example here that says, what if you wanted to solve this equation that says sine x equals 1/2? This is really just asking you to find any angles where the sine of the angle is equal to 1/2. Well, this is a job for your unit circle. So what you can do is go to the unit circle and look for any angles that have the sine equal to 1/2.
5 pi over 6 and pi over 6.
Yep, so remember the sine is the y value on the unit circle. So I'm going to go to the unit circle. I'm looking for the y.
And cosine is the x, the cosine.
Yep, cosine is the x. So I'm looking here. I'm noticing this y value is 1/2. So an answer here is 30 degrees, but there might be more than one answer. So I
And
keep
150.
looking. Yeah, here's another answer where the sine is 1/2. So 150 degrees is another answer.
Excuse me, like how do you find the tangent how do you find tangents? Like, do you have to divide the sine and the cosine to get the tangent, or?
That's it, right, Janara? Yeah, the tangent of any angle is equal to the sine over the cosine.
Okay, that's I just wanted to know. Like, if it's asking for a tangent, then I'll divide both numbers for that.
That's right. And so what you could do if you wanted to find the tangent of, let's say, 60 degrees, is take the sine value here and divide it
By the
cosine. All right, so that was just some background. Let's go and do this problem, though. So this problem is giving me secant x sine x minus 2 sine x equals 0. Well, I'm going to use a little trick from algebra. If you remember, if you could get two quantities multiplying and the result is 0, when you have this kind of a setup, you break this up into two equations where you let a equals 0 and b equals 0. So what I'm going to do is try to rewrite this left side as a multiplication. Well, really, that's the definition of factoring. Factoring means rewrite as a multiplication.
So we got, so this question right here, we got 4 answers we got.
We could have multiple answers. Yes, that's right, Janara. So let's take a look at this. Let me factor the left side. Well, I'm noticing that the sine x is in common because there's a sine x in the first term and there's a sine x in the second term. So I'm going to pull sine x out in front of a parenthesis. Well, if I pull sine x out, I pulled this guy out in front, I pulled this guy out in front. That leaves me in the parenthesis with secant x minus 2. But now I really have one parenthesis times another equals 0. Well, that allows me to set each one of these parentheses separately equal to 0. So now I'm setting separately. Whoops, I'm sorry, I should write this as minus 2 equals 0. Now I'm going to solve these two equations separately. Let's go to the first equation. It says sine x equals 0. So I'm going to go to the unit circle and look, where is the y value equal to 0?
Oh, it's a pi and 2 pi.
Yeah. Now, one thing I got to be careful about, Gennaro, is notice in the requirements for this problem, it says my answers have to be in the interval from 0 to 2 pi, but there's a parenthesis on the 2 pi. That means 0 to 2 pi, but not including 2 pi itself. That's what the parentheses means, if you remember this from interval notation. So that means I cannot use 2 pi as an answer. I'll write this in degrees. It would be from 0 to 360 degrees, but not including 360 itself. So my answer could be 359 degrees, but it can't be 360 degrees. All right, let me go to the unit circle, and I'm looking for where the y value is equal to 0. Well, I'm noticing right here the y value is equal to 0, so that means 0 degrees is an answer. I'm coming over here. I'm also noticing a y value of 0 here. That means 180 degrees is another answer. I also notice this y value is 0, but I can't use 360 because it was just not allowed as part of the conditions for this problem, right? The condition said you cannot use 360 degrees or 2 pi itself. All right, so that's the answer for this one equation. Let's go over to the other equation. Well, on this other equation, let me add 2 to both sides to get started here. So this is going to be secant x equals 2. But I don't want to use secant x because secant is not on the unit circle. Instead, I'm going to rewrite secant as 1 over cosine. Right? And let's say you forget that secant is equivalent to 1 over cosine. I can come over here to this identity right here, and notice it says secant theta is 1 over cosine theta. Okay, so that's a reminder. All right, well now let me do a little cross multiplying. So I'm going to take this 2 and put it over 1. Now I'm going to do a little cross multiplying trick. That's going to tell me that 2 cosine x equals 1. Right, this is after cross multiplying. And now I want to get cosine x by itself. So let me divide both sides here by 2. So I'm ending up then with cosine x equals 1/2. Now I can go back to the unit circle. I want to find any angles
Come on, get out of there.
that have the cosine equal to 1/2. Well, I know the cosine is the x value on the unit circle. Well, here's one angle where the cosine is 1/2. So 60 degrees is going to be one answer here. Is there anywhere else where you notice the x value on the unit circle is equal to 1/2? Well, if you look way down here in the right-hand corner, here's another x value that's equal to 1/2.
300.
That angle is 300 degrees. Okay. And of course, I could write these answers in radians if I wanted to. You know, I could write this as 0 and pi over here for those angles. 60 degrees is pi over 3. 300 degrees is 5 pi over 3. So I could write the answers in degrees or radians. That's up to me. But like Gennaro said, there's 4 answers to this problem.
Like if you do 0 will be just pi. It'll be 0 pi. 0 and pi. Then for 180, I already did the 0 pi 180. Then I need the 60. That's for pi over 3. And then the 300 is for 5 pi over 3.
Yeah, so let me write the answers out, Gennaro. Let's just to clarify for other students. Let me write the answers, and let me write them either using degrees or radians. Remember, you can use either method. This would be up to you. Degrees, we would have 0 degrees.
Hey, you too.
180 degrees, 60 degrees, 300 degrees. Those are the 4 answers.
Out.
And the radians versions.
In radians, the version would be 0, pi, pi over 3,
No.
and 5 pi over 3.
Out.
Okay?
Sir.
Folks, if
Sir.
you wanted to, you could actually check your answers by plugging in any of these angles back in the starting equation. You would convince yourself that the starting equation is valid, and that would convince me that my solutions are correct. Okay? Any questions on this example, folks? So really what we had to do for this one to get started is we had to factor the one side of the equation. Then we set each parenthesis equal to 0. And then we solved each equation separately. And then went to the unit circle to find the angles that satisfied each one of those equations. All right, should we go to let's go to the next one. All right, let's take a look at this example.
Hey, you too.
All right,
Chuckle
so
and fuck.
here they're giving me a triangle, and they say find the length of side A. Okay. By the way, folks, if anyone's not asking a question, if you could mute your microphone, that would help with background noise. All right, let's take a look at this example. Now, the first important thing to notice here is, notice it says this is not a right triangle. So I can't use sine theta equals opposite over hypotenuse, for example. Can't use this. This formula is only for a right triangle. But I don't have a right triangle here. When you have a non-right triangle, your only options are to use what's called law of sines or law of cosines. Okay, and maybe you don't remember law of sines, law of cosines, so let's jump down.
Wait, actually, I remember the law of sines and cosines.
Excellent, good. In case you don't, here are the formulas. Now remember, it's a good idea to try to use law of sines first because that's easy to work with. If law of sines doesn't work, then you can turn to law of cosines. So I'm going to write down here law of sines. Okay, so I'm going to write it as sine A over A equals sine B over B equals sine C over C. All right, so let's try and see if this
So that this part right here, like a 45 could be alpha. Then we could do C will be the gamma, and then 30 will be the beta.
All right, so Gennaro says, why don't we label the triangle like this, ABC, right? That's perfectly valid. You can label the triangle any way you want, but because I see a lowercase a here, I want to put angle A opposite the side. So that means that this side 5, I'm going to label as lowercase b. And this side over here, I'm going to label as lowercase c. All right, now remember, they want me to find side A.
Okay, so to do that, we have to use the law of sines. We have to use.
Yeah, let me circle what we're given. Well, we're given all 3 angles. So I'm going to circle all 3 of these angles because those are known. They're also giving us side B. So I'm going to circle B. A is unknown. Well, I'm noticing if I focus on this equation right here on the left side, this is going to work because I know 3 of the 4 unknown quantities in this equation. That means the law of sines is going to be usable. So let's go plug into this law of sines. On the top here, I'm going to put sine of A, but angle A is 45 degrees. Side A is unknown, so I'm just going to leave that as the letter A. Let me go to the right side here. Sine of B, well, angle B is shown as 30 degrees in this diagram. And on the bottom here, I know side B is 5. Okay. Now, folks, remember, when you go to take the final exam, you don't have a calculator. But the nice thing about this example is I don't need a calculator because sine of 45 and sine of 30 degrees are available to me on the unit circle.
Yeah, like, first of all, like, how do you, like, I know how to crisscross multiply. Like, how do you, like, simplify together without a calculator?
Yeah, let's do it, Gennaro. So how do you work this out without a calculator? Well, the first thing I'm going to do is let me go to the unit circle and write down, let me write down the values for sine 45 and sine 30 so I can plug into this equation.
The sine 45 is square root 2 over 2.
Yep, so I'm coming here to the unit circle. Sine of 45 is this guy right here, right? So I'm going to write this as the square root of 2 over 2 divided by A. And that's equal, so this was the sine of 45 here. And that's equal to the sine of 30. Well, the sine of 30 degrees is right here, 1/2. So that's going to be equal to 1/2 over 5. All right, well, now I do have one fraction equal to another. And when you have one fraction equal to another, you can cross multiply. So let's do that. I'm going to multiply this way and set it equal to the multiplication this way. Okay, so it looks like I have 5 times the square root of 2 over 2 equals a over 2. Right, so I multiplied on this diagonal, and then I multiplied on this.
A over 1 over 2.
Right, I could write it as a times 1 over 2 like this. But now, notice I still have one fraction equal to another. So how about if I cross multiply again? Remember, I'd like to get rid of fractions, because if I can get rid of fractions, the equations are always easier to solve. So let me cross multiply one more time. So I'm going to multiply this way and then multiply that way. So I'm going to have 2 times 5 square root of 2, and that's equal to 2a. But remember, I want to get a by itself. So because a is being multiplied by 2 right now, let me divide both sides by 2 to get a by itself.
Then you get like the square root. Then you get like 5 square root 2 over 2. Then
Well, Gennaro, this 2 here in red cancels with the blue 2 on the bottom.
Then you just put 5 square root 2.
You got it. That's it. Yep. A is just 5 times the square root of 2. Okay. And remember, in WebAssign, you leave your answer as 5 square root of 2. You don't work it out on your calculator to get a decimal answer because you're not going to have a calculator available. So you would just have to leave your answer as 5 square root of 2. All right, folks, so this was a little bit of a tricky problem because you had to recognize that this was a non-right triangle. That meant you could only use law of sines or cosines. We tried law of sines to begin with, and it was our lucky day because law of sines worked. Then we cross-multiplied, and we were able to solve for a. And of course, we looked up sine 45 on the unit circle. We looked up sine 30 degrees on the unit circle. All right, folks, any questions on this example? And again, notice how this example did not require a calculator. All right, let's keep going. Let's do a few more examples then. All right, here's a problem that says convert this Cartesian equation to polar.
You have to do like the r squared. You have to do.
Yep, so remember when they say Cartesian, they really mean xy. So notice this is an equation that involves x's and y's, but I want only r's and thetas in my final answer.
Yeah, you have to do like 6 squared plus 6 squared. They have to do.
Yeah, let me jump, Gennaro, let me jump down to some formulas that might come in handy. So these formulas right here are ways to convert from rectangular to polar. Okay? So remember, I want to get rid of x's and y's and only end up with r's and thetas. So let me start out looking here at the left-hand side. I'm noticing an x squared plus y squared. But here I'm noticing that x squared plus y squared can be replaced with r squared. So I'm going to replace this guy with an r squared. So now I have r squared equals 6y. But again, I want to get rid of x's and y's. So I want to try to get rid of this y, replace it with an r theta. Well, let me come over here. It says y is r sine theta. So I'm going to replace this y with r sine theta. And really, this is a good answer in the sense that I have gotten rid of x and y's, and I only have r and theta in my answer, but I can do a little simplifying here. Algebra tells me there's an r on the right side and an r on the left side.
Divide it.
Divide both sides by r just to simplify this formula a little bit.
R equals 6 sine theta.
Yep. So on the left side, r squared divided by r is just r. Remember, this is r to the 1. So you subtract exponents. You might remember a property that says if you have x to an exponent divided by x to another exponent, this property says you subtract the exponents. And on the right side, the r's cancel out. So the final answer here is r equals 6 sine theta. Okay. Folks, please ask questions if anything here is not clear. Let's go do a few more examples. All right, let's go here to number 20. Number 20 is asking us to work with vectors.
For this one right here, you have to multiply the part that says 5v. You have to multiply the v to v equals negative 3i minus 5j.
Yep. Now, you might remember, folks, a vector is a directed line segment. You can think of it as, right? So a vector is giving you an indication of both a direction and an angle. So there's an angle and a direction. And we also used unit vectors. So for example, the vector u, remember I is the unit vector in the x direction, and j is the unit vector in the y direction. So it's almost like x and y coordinates. This would be telling me go over to the right 1i, that would be the vector 1i, but then also go 4j in the vertical direction. So vector u would really be a vector that looks like this blue vector here. So the blue vector here would be vector u. All right, well, all they want me to do here is take vector v and multiply it by the number 5, then take vector u, multiply it by the number 3, and then add those two results together. And you might remember this is actually a problem that's really just equivalent to combining like terms from algebra. So let me take 5 times the vector v. Well, the vector v was given as negative 3i minus 5j, plus 3 times the vector u, that was given as I plus 4j. Well, now I can really just use like a distributive property to multiply this number 5. By the way, we call this a scalar, right? This number 5 is called a scalar. So I'm going to multiply that inside the parenthesis. That's negative 15i minus 25j. And in the back here, 3 multiplies inside the parenthesis. So that's going to be 3i plus 12j. Now, because the I vectors are pointing in the same direction, I can add them just like you're combining like terms. So negative 15i plus 3i.
I get the answer of negative 12i minus 13j.
You got it. That looks good. Yeah. Because when I combine the I and the j terms together, right, we end up with negative 12i minus 13j. Folks, remember to be careful that when you enter this answer in WebAssign, the I has to be entered from the vector menu.
Vector version.
Yep, a vector version. And for that, you go to the math menu in WebAssign, and there's a vector menu to select from. And when you go to that vector menu, you'll see the vector I is there and the vector j is there. Right, remember folks, don't use the letters I and j from your keyboard, because then the answer will be marked wrong. All right, folks, let's go to number 21 here. This one is asking me to convert XY coordinates to polar coordinates. Okay. All right, well, really what they're giving me here is X is 6 and Y is 6. If I was to graph that, of course, that means that we're talking about this point on the XY coordinate system. We're at that point right there. We want to write this in an alternate way. We want to write this as the distance r and the angle theta. Well, let's first find r. I can use this formula right here to figure out r. So r squared is x squared plus y squared. Well, that just means r squared is 6 squared plus 6 squared. But that means r squared is 36 plus 36. That means r squared is 72. And I'll take the square root of both sides. So r is the square root of 72. I could simplify this if I wanted to, because when I look at the number 72, I notice it's really 36 times 2. Then I can separate this into 2 separate square roots. But I know the square root of 36 is just 6. So that's the answer for r. So
Okay,
our answer for r here is either, I could write it as r is the square root of 72, or if you want to clean it up a little bit, you can write it as 6 square root of 2.
like Web we'll take like either one then.
Take it either way. Exactly right. Yep. All right, well, let's go to theta. That's the only other unknown. Well, there's a couple of ways I could do this. Let me come here to tan theta. Maybe let's use this formula. Maybe this is the easiest way to go. So how about if I think about tan theta equal to y over x? Well, in our example, y is 6 and x is 6. So that means tan theta is 1. Now I'm looking for the angle whose tangent is equal to 1. Let me go back to the unit circle and see if I could do a little bit of detective work
45.
on the unit circle. Yep, the answer is going to be 45 degrees, as Gennaro says. But why is the answer 45 degrees? Well, what I'm remembering is that the tangent is equal to sine over cosine. But we just figured out that this tangent has to equal 1. Well, if the tangent is 1, really what it's telling me is the sine and the cosine must be equal to each other.
It's like the same thing.
It's got to be the same value, yeah, because the only way to get a fraction equal to 1 is the top and the bottom of the fraction have to be the same value. So I need an angle where the sine and the cosine are identical. And as Gennaro said, I can look over here to 45 degrees, and the sine and the cosine are identical. So that means theta is 45 degrees. And of course, we could write it as pi over 4 if you wanted to write it in radians.
Like don't take it no matter what.
Either, yep. When you go to enter angles, you can either enter angles in radians or degrees, unless a problem specifically says enter your answer in radians. But if it doesn't say that, then you're free to enter the answer in either radians or degrees. But folks, in WebAssign, please remember, if you want to enter your answer as 30 degrees, you've got to put this degree symbol with it. Right? So if you want to enter an answer in degrees, make sure you put a degree symbol in your answer. All right. Folks, we have a couple more examples left, so let's take a look at those. Let me scroll down and all right, let's take a look at this. The first one says convert polar to Cartesian. So this is the opposite of what we just did. What we just did a second ago is we converted Cartesian to polar, but now they want us to go the other way. So let me go to this summary again. Here are the formulas to help us out. So remember, what they're giving us in polar form is an r theta value here, right? So in our example, r is 4 and theta is 60 degrees. But the question here is find the xy coordinates. Remember, when you see the word Cartesian, Cartesian means xy. All right, well, I have two formulas here that'll do the job. So I know that x is r cosine theta and y is r sine theta. I know r and theta, so I'm just going to plug in. So this is going to be 4 times cosine 60 degrees. And for the sine, it's going to be 4 sine 60 degrees. All right, let me scroll back up to the unit circle. And I'm going to go to 60 degrees. So let me plug in. The cosine of 60 degrees is this x value. So that's 1/2. So it looks like the x value here is 2. So we're ending up with x equal 2. Okay, let me go to sine 60 degrees. Well, when I look at sine 60 degrees, I'm seeing the square root of 3 over 2. So this is going to be 4 times the square root of 3 over 2.
There is one right here, like you have to do 4 times 3, then divided by 2 then.
Yeah, this 4 on top cancels out with the 2 on the bottom. It's leaving just a 2. So 2 square root of 3. So the y value is 2 square root of 3.
So those are the answers then?
These are the answers, right? X equal 2 and y equals 2 square root of 3. If I wanted to write it in XY notation, I could write it as 2 comma 2 square root of 3. Let me do a quick sanity check. Does my answer really make sense? Well, how about if I was to graph the polar point that they gave us? So let me do a quick graph here so we can check this out. Okay, so let me draw a little graph. And the polar point is rotate 60 degrees and walk out a distance of 4. So that's going to be this point right here. All right. Now, let me check out. What if I was to graph 2 comma 2 square root of 3 on the same graph paper? Well, let me just estimate 2 square root of 3. This is about, the square root of 3, I think is about 1.7 roughly. So this is going to be roughly 3.4. So I'm going to go horizontally 2, and then I'm going to go vertically about 3.4. And notice that would take me to the same dot. So a quick graph here just kind of gave me confidence that my answer makes sense, because when I plot 2 comma 2 square root of 3, it gets me to this about the same location as if I plotted 4 comma 60 degrees. Right? If my XY point ended up being way out here or way down here, I would know these answers are wrong because it wouldn't be in the same vicinity as the r comma theta point.
How'd you get the 1.7?
What I did, Janara, is I went to my calculator. And I know you're not going to be using a calculator, but you know, if you think about the square root of 3, I know the square root of 4 is equal to 2. So the square root of 3 has to be a little less than 2. And I just kind of know from my own experience that the square root of 3 happens to be 1.7. You can work that out on your calculator also. But I know it has to be a little less than 2 because the square root of 4 is 2. So the square root of 3 has to be a little smaller. Okay. Folks, you don't have to worry about this double check if you don't want to do it. I just wanted to mention that you can at least do a little sanity check like that. All right, folks, let's go to the last example, number 23. All right, let's take a look at this one. Now, I'm noticing for this example that it's a non-right triangle. How do I know that? How do I know this is not a right triangle? First of all, it says it in the problem. That's one clue.
That
But
60 is the
also,
gamma.
yeah, I'm also not seeing any angle that's labeled with the square in it, in the corner. Remember, if there's a square in the corner, that tells you it's a right angle. We don't have that. All right, I can't use sine theta equals opposite over hypotenuse, right? Because this only works for right triangles. Could I use Pythagorean theorem here? A squared plus B squared equals C squared.
That's for, we can also use a law of cosines. We can also use.
Yep, I can't use A squared plus B squared equals C squared because this only is valid for right triangles, and this is not a right triangle. So remember, for non-right triangles, you can either use law of sines or law of cosines.
Let's do law of sines for this one.
Let's try law of sines because, Janara, if it would work, law of sines is usually easier. First thing I'm going to do is label the triangle.
This is for y right here, gamma.
So this side is C, so I'm going to label this side as capital C.
And A will be right here.
Janara, are you pointing up here in this right corner? This upper
Yeah.
right? Okay, so let's label
Okay.
this as A, and we'll label this here as B. Remember, you don't have to label it this way. You can label it any way you want, but we're going to label it this way. That means this side is lowercase b, and this side is lowercase a. All right, I'm going to write out law of sines. Let's do it. So law of sines is sine A. Before I do that, let me scroll down to law of sines and law of cosines so we have it. All right, here it is. So Gennaro suggested, why don't we try law of sines to begin with? Okay, let's do it. I usually write it as sine A over A equals sine B over B equals sine C over C. And then I'm going to circle the quantities that we know. We know angle C, that's given in this problem. We know sides A and side B, and that's it. Can we use law of sines?
No.
We cannot. The reason is you would need to be able to set two fractions equal to each other where you know 3 out of the 4 quantities in the equation.
Actually, if we do law of cosines, we can do c squared equals a squared, which is 5 squared, then plus.
Yep, Gennaro, hold on a second, Gennaro, let me write it down. So let's use law of cosines as Gennaro suggests. That's our backup plan. Now I need to know which one of these options. I have formula 1, 2, or 3 here. Well, notice we know angle C. So I'm going to use this bottom option because that's the only formula that involves angle C. So let me write it. It's C squared is A squared plus B squared minus 2AB cosine C. All right, well now let me fill in all of the quantities that we know. Side A is 5, so that's 5 squared. Side B is 10, so that's 10 squared. Minus 2 times A, that's 5, times B, that's 10, times cosine of C, but angle C is 60 degrees.
Then if you do everything right here, 5 squared is 25, then 10 squared is 100, then 5 times 10 will be 50, and then times 2 will be negative 100.
So this is 2 times 5 is 10, times another 10 is 100. Yep.
And the cosine of 60 is 1 over 2.
Cosine 60 is 1/2. You got it. I got that from the unit circle. Now, folks, here's where you got to be careful. I need to follow order of operations when I work this out.
It's like for this one, you could do 100 minus 100 is 0, then you just leave off with 25.
But Gennaro, here's a problem. You said work out 100 minus 100, but you're doing the subtraction first. That's not right. Order of operations says I have to do multiplications before subtractions. So that means I've got to do this multiplication first.
So if you do 100 times 1 is 100, then divided by 2 will be 50.
So this 100 times 1/2 is 50. You got it. And now I got to be careful again because order of operations says when you're adding and subtracting, you've got to go in order from left to right. So I'm going to add 25 and 100. That's 125. And then 125.
75.
Subtract 50. So it looks like C squared is
75.
75. Take the square root of both sides. So C is
15.
the square root of 75. Now I could leave the answer like that, or I could simplify this a little bit because I could rewrite 75 as 25 times 3. Then I could write that as the square root of 25 times the square root of 3. But I know the square root of 25 is 5, so 5 square root of 3. So the final answer to this question, remember they asked us to find side C. I could either write C is the square root of 75, or I could write C equals 5 square root of 3. Either one of those answers are correct. Folks, any questions on this example? And again, notice we did this problem without a calculator, right? Because it so happened the angle here was 60 degrees, and cosine 60 was available to me on the unit circle. I didn't need a calculator to evaluate it. I know many WebAssign homework questions, you did need a calculator, but on these final exam questions, the questions are designed where you don't need a calculator.
I mean, like you can just use the formulas.
You can use these formula sheets, and you are going to need quite a few of these formulas, folks. So be sure to familiarize yourself with this reference packet, right? So you know where the formulas are located, and you also know what formulas you have at your disposal. Folks, any questions at all on this final, this practice final exam?
So far, like the questions are like they'll be the same type of questions, but similar.
Yep. Gennaro, when you go to take the final exam in WebAssign, the questions are going to be very similar to the examples we've done here on the practice final, and they're going to be very similar to the homework problems.
Yeah.
In fact, Gennaro, the final exam are the similar problems taken from the homeworks.
So like it's like the exact homework questions.
It's the similar homework questions, but the numbers are changed a little bit. It's not going to be exactly the same problem you did in the homework. The numbers are going to change a little bit because, Gennaro, what happens is when you see these red numbers here, see these numbers in red? That means WebAssign has come up with these random numbers.
Yep.
So you, Gennaro, you might get U equals I plus 4J, but another student might get U equals I plus 8J.
So every test is like different than
Every test is going to be different, and that's why it's going to be slightly different from the homework problems, because you're going to see new numbers appear in these examples. And again, anywhere WebAssign shows these red numbers, is where WebAssign is randomizing the problem.
So like for number 10 right there, for like sine over, like the inverse sine of -1, like square root of 2 over 2, you just get it on the unit circle. If you get the square root of 2 over 2 for sine, it's 45 degrees.
You got it. Yep. So you go to the unit circle, look up what angle has its sine equal to square root of 2 over 2. And you're right, the answer is 45 degrees.
And for number 11, for cosine of -1, like if you get negative square root 2 over 2, like there's like right here, there's like a 5 pi over 4 and a 3 pi over 4. There's like two of them answers like that.
That's right. So Gennaro, what answer would you go with as your final answer, or would you use both answers?
The answer I will go with is 3 pi over 4.
Yeah, and how did you know that?
Because it has to be like no more than 180.
You got it. Good work, Gennaro. Exactly right. When you work out the inverse cosine, remember your answer must be between 0 and 180 degrees. That's a requirement for inverse cosine. For inverse sine, the requirement is the answer must be between -90 and +90. So just make sure that your answers are falling in the allowed interval, the allowed range for the inverse sine and inverse cosine.
Let me just write this down real quick so I don't forget.
Folks, any other questions? All right, folks, please, I'll be checking emails often this weekend. So as you're reviewing and working on the practice final, please email me with questions, or if you want to text me or call me, please do that. Here's my phone number, 610-217-5843. Feel free to call or text or email.
Oh, I also got to show you something on my web assign. I got to show you real quick.
Okay. Folks, if anyone doesn't have questions, you want to log off, please feel free to log off. I'm just reminding you about my email address, lsm7@psu.edu, or you can email me directly in Canvas. So please don't be shy about getting hold of me. I'll be glad to help if you get stuck on any questions as you're preparing for the final. And then I'll see you on Monday at 10 a.m. And remember, you're going to log into Zoom with your phone, and you're also going to log into WebAssign with your laptop. Okay? All right, folks, thank you for joining. Also, by the way, folks, thank you for all your efforts in the course. You know, we covered a lot of material here. We had the extra challenge this semester of going to the online format. And so thank you for, you know, continuing to work from home on all of our course materials here. And again, I'll see you on Monday for the final exam. Okay? All right, thanks everyone. Janara, I'm going to stick around because I think you had another question.
Oh yeah, let me just share my screen real quick. If I
Let me see, Janara. I think I have to let you do that.
okay.
Let's see. I think I have to make you a co-host. Let me try that.
Like for this one right here, like.
Hang on, Janara. I can't see your screen yet.
Oh, okay. I'm the co-host. Okay, so.
Now you're the co-host. Now I think you should have a button that says share.
Yeah, share screen.
Can you do that? And then I think I should be able to see your screen.
It says this will stop other screen sharing. Do you want to continue?
Say yes.
Okay. Let me log into WebAssign real quick.
Yeah.
Okay, WebAssign. Right here. It's gonna take a while.
No problem. Yep.
If I go to 9.1, or let me check 9.1 if they have those like oh, like those kind of versions, like this one, like the fundamental identities, like
yeah.
I tried doing this one, like for instance, like I did a sine x, cosine x.
Now, Janara, let me mention to you that what I'm seeing here is sine of negative x.
I'm doing the second one, number 2. I'm doing.
Oh, I'm sorry, number 2. Yeah,
Like to do this one, like to find a secant, they have to do like the cosecant. If I check on my reference sheet, the cosecant is 1 over sine x.
exactly. Yeah.
Then to do that, then you have to bring everything down then.
Well, if you replace cosecant with 1 over sine,
Yep.
notice you'll have a sine on the top and a sine on the bottom.
Yeah, like so it's I wrote sine x times cosine x times 1 over sine x.
Exactly, yes. And now you can cancel out the 2 sine x's because you have a sine x, really, you can think of it as like on top and a
Then
sine x on the bottom of a fraction.
Yep.
Cancel those out.
So then I'm only left off with cosine x times 1, so we just cosine x.
You got it. So that's the final answer on that one.
I want to try also number 3. I wanted to try.
Okay.
For this one right here, like says sine x.
Now this one's a little tricky because notice it's giving you negative angles. So the first thing is let's get rid of negative angles. And if you go back to the formula sheets, you'll notice that there's a formula that says the sine of negative x is equal to negative sine of positive x.
Yeah, so this one, like for like sine is like 1 over cosecant, then cosine is 1 over secant, then cosecant is 1 over sine.
Yeah, Gennaro, but let's keep everything in terms of sines and cosines, because that's going to make it easier to work with. So here's what you could do. Replace sine of negative x with negative sine x.
Negative
Okay.
sine x. Then cosine will be negative cosine x.
Well, though, that's not right, because if you go to the formula sheets, you'll see that the cosine of negative x is equal to just cosine x.
It'll be times cosine x.
So it's just going to be times cosine x. That's it. Yeah.
Then for the cosecant, it says negative cosecant x.
Right. So that's going to be a negative cosecant x. But now notice that you have a negative times a negative.
It'll be a positive.
So that's going to be a positive. So now what I'm going to write down is sine x times cosine x times cosecant x.
Everything will be all positive.
All positive now, yes. But cosecant, I'm going to replace with 1 over sine x.
It's like this. It's like the same thing as we did before.
Now it's the same as problem 2. You're exactly right. The sine x's are going to cancel out, and I'll be left with just cosine x. So that's why the final answer here is cosine x.
Also for number 4, I wanted to try right here is that's number 4 is the one that we tried before.
Yeah.
So we could do number 5 then.
Okay.
Number 5, like we could say secant of x plus sine x, then tangent of negative x.
And again, Gennaro, a good first step here is get rid of negative angles.
Yeah, if we go like a tangent negative x, like it'll just be negative 10 tangent.
You got it. So what I can really write this as is secant x minus sine x tan x.
X, and then 10x.
All right, now let's get rid of secants and tangents, because remember, we want to write this all using sines and cosines.
I wrote secant of x times negative sine x times tangent of x.
Say that one more time, Gennaro, sorry.
I wrote secant of x times negative sine x, and then times tangent of x.
Well, Gennaro, you're putting in a multiplication symbol, but there is no multiplication symbol there. Notice this was a plus sign to begin with here.
Okay, so it's secant of x minus sine x plus 10x.
Times tan x.
Okay. Now I'm right.
Okay, now let's replace secant with 1 over cosine x.
So
Remember,
1 over cosine x I wrote down the minus sine x.
And let's replace tan x with sine x over cosine x.
Sine x over cosine x. And if I that, then it's cancellation right now here.
Well, here's what I'm left with. I'm gonna have 1 over cosine x minus sine x times sine x over cosine x.
That's what I have.
You agree? Yep. Okay. Now let's multiply the sine x times the sine x on the top of the fraction there.
Okay, so it's sine x times sine x.
Yep, and that's sine squared.
So then it becomes like 1 over cosine x. 1 over cosine x, then times sine squared x over cosine x.
Yeah, but it's a subtraction sign in the middle, right? So it's subtraction in the middle.
Okay, so sine x minus sine x. That's what I got.
All right, here's what I have, Gennaro. Tell me if this is right. 1 over cosine x minus sine squared x over cosine x.
Over cosine x.
Does that make sense?
Yeah, like so 1 over cosine x minus sine squared x over cosine x.
Good. Now notice you have the same denominators. Well, when you subtract fractions, let's subtract these two fractions. The way you do it is you keep the denominator the same.
Like the bottom part then.
The bottom part stays the same as cosine x. And on top now I'm going to have 1 minus sine squared x.
Then to do that, like you're
Now
asking.
here's the trick.
Yeah.
When you look at the top of this fraction, you're seeing 1 minus sine squared x.
Yep.
Go back to a very famous formula. There's a famous formula that says sine squared x plus cosine squared x equals 1.
1. That's what I
Now,
got.
if you take that formula, subtract sine squared x from both sides of that equation.
Subtract it or multiply
Yeah,
it?
subtract it. So write down this formula. Sine squared x plus cosine squared x equals 1.
Okay.
Right, that's a famous formula.
I wrote it.
And now, from both sides of that equation, subtract sine squared x.
Okay. Okay, sine squared x minus sine squared x. I wrote sine squared x minus sine squared x. That's what I wrote.
Yeah, now, Gennaro, how about if I share my screen? Maybe it might be a little easier.
Okay.
So let me, I think you might have to say, oh, I can do it, okay. All right, I'm gonna go back to my screen, okay?
Okay.
And you can see my screen now?
Yeah, I can see it.
Okay, so let me go back to, let me work this out from the start. So here's the problem you were working on to begin with. It was secant x plus sine x times tangent of minus x, right? This was our starting problem. But I know tan of negative x is really going to be minus tan x, right? That's from the formula sheets.
Yep.
Okay. What I'm going to do here is I'm just going to move this negative sign out in front. So I'm going to write this as secant x minus sine x times tan x. All right. Now let me get rid of secants and tangents and replace them with sines or cosines. Well, I know secant x is the same as 1 over cosine x. And I also know tan x is sine over cosine. All right, what I'm going to do is multiply these two back fractions together. If you want, I could put sine x over 1 to make it look like one fraction multiplying another. So now I have 1 cos over cosine x minus, here's a sine times another sine. So that's sine squared over cosine x. But I'm subtracting fractions where I have the same bottom part. So the rule is keep the bottom part the same. And now I'm going to subtract the numerators, or subtract the top parts. So that's going to be 1 minus sine squared x. But there's one more step. Because this top part, 1 minus sine squared x, I can replace with an expression. And here's how I'm going to do it. I'm going to start out with the famous sine squared x plus cosine squared x equals 1. Okay? But I know the top of my fraction is 1 minus sine squared. So I would like to somehow get this equation to look like 1 minus sine squared. So I'm going to do a little trick here. I'm going to subtract sine squared from both sides of this equation. Well, then this is going to cancel out. It's going to leave me with just cosine squared x equals 1 minus sine squared. The reason I did that is I know the top of our fraction is 1 minus sine squared. But now I'm seeing 1 minus sine squared is the same as cosine squared.
Okay.
So I'm going to replace this top with cosine squared x. But now I have a cosine squared divided by a cosine. My final answer then is just cosine x.
That's the answer.
This is a bit of a tricky question because you had to recognize that when you ended up with this 1 minus sine squared on the top of the fraction here, you can actually rewrite it as 1 minus sine squared equals cosine squared.
Yep. Maybe let me check if I have some more. Let me check. Let me check if I have more of them.
Okay.
Can I have you on my screen real quick?
Yeah, let me let you share.
Okay. No, let me go back to my right here. Yeah, you can see my whole screen now.
I can, yes. I can still see it, yeah.
I mean, there's some like, let me go back to the normal. Let me go back to some more right here. If I check number 9.2, and there will be some more for 9.2. For this one right here, like, I tried to do this one without a calculator. I still got the same exact answer for this one.
Oh, good.
How do you get the those ones right here for 7? How do you do that?
All right, so this is a little bit of a challenging problem. Now, one thing I'll say, Gennaro, is notice this type of problem was not on the practice final.
Yep.
So what it means is you're probably not going to see this type of problem on the final exam.
Yeah.
But let's do it anyway.
Wait, so like which ones are gonna be a part of the exam? For like what kind of questions will be in?
Well, exactly the ones we just did on the practice final.
Okay, so like, will this one be on the final exam? This one?
I don't think these kinds of questions were on the practice final.
Okay, like which one of
And
those?
if you look at number 8 and 9,
Yeah.
notice number 8 and 9 say, find the answer using a calculator.
Yeah.
Those problems I can't put on the final exam because remember, you don't have a calculator allowed.
Yep.
So I can't ask you to solve those kinds of questions on the final exam.
Would this be on the final exam or?
I don't think this problem was on the practice final, Gennaro. We could do any of these if you want, but
What does number 5 will do?
number 5, I think, was on the practice final. Do you remember this problem on the practice final?
Yeah.
Yep.
We'll do it no
So,
matter what.
are you okay with how you did number 5?
Yeah. So I mean, I just want to review for this one because the numbers might change. It probably could be like 3 pi over 4. Besides, like
Could
here it's
change. You're right. You're right. Yeah. So the key to this one, Gennaro, is recognizing that the expression they're giving you
Yep.
is cosine parenthesis a minus b.
Oh, so you have to use it says. So it's the sum of differences formula we have to use.
Exactly. Exactly.
So
You're
like
going to match this up to cosine alpha minus beta.
so cosine x, then cosine 3 pi over 4, then plus sine x, then sine 3 pi over 4.
You got it. And then
And
the
cosine.
sine and cosine of 3 pi over 4, you can look up on the unit circle.
Okay, if I look up on a unit circle 3 pi over 4, and I get and here it says like one's gonna be negative, one's gonna be positive. So it'll be cosine x times negative square root 2/2 plus sine x, then and then it'll be positive the next one, square root 2/2, and it'll be times.
You got it. So you can see that your answer that you just came up with matches the correct answer that I'm seeing on the slide.
Also for this one right here, it also might be also a sine one version as well if you change it.
Yeah. So on this one, Gennaro, it's going to be very similar. Notice this problem is,
But we could try 4.
yeah. So if you try number 4, notice the setup of that problem matches sine parenthesis a plus b.
Yep. So
So look for a formula that says sine parenthesis alpha plus beta.
oh yeah, it's like sum of difference formulas for sine. That's what I have.
Exact. You got it. Yep.
I mean, I just want to review more because I really want to do well on the test.
Got it. Yeah, definitely.
So then sine x and cosine 5 pi over 6, then plus cosine x, then sine of 5 pi over 6. Then also, like if I do this, I could check on the unit circle for 5 pi over 6.
Yep.
Then for cosine, I get the answer of negative square root 3/2 times negative 3 square root 2 plus cosine x. And the sine of 5 pi over x is 1/2. And that's the answer I got.
Yep. Looks good.
Like, we don't even need a calculator.
Right. Yes. Some of these problems you're not going to need a calculator.
Also, for like those ones right here, like if this could be a tangent, like we could try this one for number 3. Like you say, tangent 5 pi over 12. Like to do that, like I think, like there's no 5 pi over 12 on the unit circle. So how do you do this one?
So what you have to think about on this one, Gennaro, is because 5 pi on 12 is not on the unit circle.
Yep.
Could you write 5 pi over 12 as the sum or difference of two angles that are on the unit circle? Now,
Oh.
maybe it'd be easier to change the angle from radians to degrees.
Oh yeah. Like to do this one, like I also have the sum of difference formulas for tangent.
That would be it. You would use those, yeah.
So this one it's not showing like plus or minus. It's only just showing. It's always like it's like attached to like a multiplication.
Right. So here's what you got to do before you can use the sum or difference formulas for this.
Yep.
I'm noticing 5 pi over 12 is the same as 75 degrees.
So equals 75 degrees then.
So this problem is really asking you to work out tan of 75 degrees.
So tangent of 75 degrees, like.
But 75 degrees is not on the unit circle. So
So-
why don't you write it this way?
Yep.
Tan parentheses 30 plus 45 degrees.
So 10 parentheses 30 plus 45.
Yep. Does that make sense? Because 30 plus 45 is the same as 75 degrees. But now you've written it using two angles that are on the unit circle.
So then after this, like I have to do 10. So 10, 30 plus 45 will be over tangent of A, which is alpha, tangent alpha. Tangent will be tangent 30 plus tangent 45 over 1 minus tangent A, tan 30, and then times tan 45. That's what I got.
Okay.
Like, how do you solve this then? Like, to get a tangent of 30.
So to get tangent of 30, go to the unit circle.
Yeah.
On the unit circle, you have the sine of 30 and the cosine of 30 available, right?
So it's like 30 degrees then.
Yep, go to 30 degrees. Now, I know that tangent is the same as sine over cosine.
Yep, sine over cosine. So like, I have to do 1 over 2 times, not the 1 over 2 divided square root of 3 over 2.
Good, you got it.
Like if I do 1 over 2 divided square root of 3 over 2, like to do that, then like to get the answer, just say like be 1 plus square root of 3 over 4 then. Is that the answer?
Well, Gennaro, when you divide two fractions,
Yep.
what
The
you
bottom
do,
part is the same. The bottom part.
well, what you do is you take the top fraction
Yep.
and multiply it times the flip of the bottom fraction.
So it's like it's a keep flip change then.
Exactly. So it's going to be 1/2 times 2 over the square root of 3.
Okay, like that. Then like crisscross multiply then. Then I'll get like 1 plus square root of 3 over 4 then.
No, Gennaro, here's what I did. We started out with 1/2 divided by square root of 3 over 2. Yep, do you agree?
Yeah, I agree.
Now, let's keep the top fraction as is, multiply it by the flip of the bottom fraction. Now, what I have is 1/2 times 2 over the square root of 3.
That's what I have.
But now you're multiplying fractions. You multiply straight across to multiply fractions.
So it'll be a 1 times, so straight across, which means like left to right then.
Yep.
So it'll be 2 and then 2 over 2 to the square root of 3 then.
Yep, that's right. But now one last thing you could do is now you have a 2 on top and a 2 on the bottom.
They cancel.
You can cancel. So you're left with 1 over the square root of 3. So the tangent of 30 degrees is 1 over the square root of 3.
So it equals 1 over square root of 3 then. Then then here it says like square root of 3 plus 2 then. That's what it says on the answer sheet. And here it says the answer is square root of 3 plus 2.
Yeah, but now, Gennaro, you still have to plug into the tan A plus B formula, right?
Yep.
Did you do that yet?
I put for A plus B, I put 30 and 45. I put.
All right, Gennaro, let me go back to my screen if you don't mind.
Yeah.
Let me do that. Okay. So let me go back to my screen. And again, the problem we started out with here was tan.
I can't see your screen.
Oh, sorry. Hold on a second. Let me share. You can see it now, okay?
Yeah.
Okay. So we started out here with tan of 5 pi over 12. This was the original problem, right? Okay. But we said, let's change this to degrees just to make it easier to work with. So tan 75 degrees. But when I look at the unit circle, 75 degrees isn't there. So I said, let me instead write this as tan of 30 degrees plus 45 degrees.
Wait, when you found it, how did you find the 75 degrees? Did you do 12 times 5?
What I did is I changed radians to degrees. Here's the way I did that. You take 5 pi over 12 and you multiply it by, remember I want to change this to degrees, so I multiply it by 180 degrees over pi radians. When I did that, pi cancels out. And so now this is going to be 5 times 180 divided by 12.
Okay, now so far, like, you have to do 180 times 5.
Let's do 180 times 5. I could simplify the fraction, but let's do 180 times 5.
So 0 will be 900.
Yep. Divided by 12.
I get 75.
75, you got it, good. All right, so this is tan 75 degrees. But 75 degrees isn't on the unit circle, so instead I wrote 75 degrees as 30 plus 45. All right, now I go to the chapter 9 summaries, and I notice there's a formula for, oh no, there's not a formula for tan A plus B.
Right here.
Oh, here it is. I'm sorry. There it is right there. Yeah. So right here it is. All right. So let me write it. It's going to be then tan. So we're going to use this formula right here, right? And RA is 30 degrees and RB matches up to 45 degrees. So this is going to be tan 30 degrees plus, let me erase some of this stuff, plus tan 45 over 1 minus tan 30, tan 45. Right?
So far we found the tangent of 30, so it's 1 over 3.
So the tangent of 30, we worked out to be 1 over the square root of 3. The only other thing we need is tan 45.
How to find tangent 40? How do you find tangent 45 again?
So for tangent 45, I'm going to remember that the tangent is the sine over the cosine.
So it's just 1 then.
It's going to be 1. You got it. Good. Because sine 45 and cosine 45 are the same, so tan 45 is 1. So let's plug in now to this formula. Tan of 30 is 1 over the square root of 3.
So we have to do 1 over square root of 3 plus 1.
1, good.
Over
1 minus
square root of 1 square root of 3.
Tan 30 is 1 square root of 3
Times
1.
Like so to do this, like you have to. So the top part is that you have to do it left to right then.
You can leave your answer like this, Gennaro. So I could just leave my answer as this answer if you want to.
Well, what else is the other way?
The other way is to keep simplifying this. So what I could do here is I'd like to get rid of these denominators that have the square root of 3. Remember, I always want to get rid of fractions. So let me multiply the top and the bottom of this fraction by the square root of 3, top and bottom. I'm allowed to do that because I'm really multiplying by the square root of 3 over square root of 3, which is 1. And I'm always allowed to multiply by 1. All right, so let me do that. I'm going to multiply this inside the parentheses.
Wait, so you cancel the bottom parts? You cancel?
What I'm saying here, Gennaro, is I'm going to write it over here. Here's what we're left with at this point in time. Let me write it over here to be a little clearer. We have this fraction, 1 over the square root of 3 plus 1. And on the bottom, we have 1 minus 1 over the square root of 3, right?
Yeah.
Remember, I could leave the answer like this. WebAssign would take it. But let's clean it up. Here's what I could do. I'm going to multiply the top and the bottom of this fraction by the square root of 3 over the square root of 3, like this. All right, now I'm going to multiply inside the parentheses. All right, let me go to the top. When I multiply on the top, it's going to be the square root of 3 times 1 over the square root of 3 plus the square root of 3 times 1, which is just the square root of 3.
Yeah.
Let me go and do the same thing on the bottom of this fraction. If I go to the bottom of the fraction, this is going to be the square root of 3 times 1, which is just the square root of 3, minus the square root of 3 times 1 over the square root of 3. So I'm multiplying this guy into the back here. Okay. Let me clean this up one more time. This square root of 3 cancels out with that square root of 3. So I'm left with 1 plus the square root of 3. And on the bottom, this square root of 3 cancels out with that square root of 3. I'm left with the square root of 3 minus 1.
That's the answer.
This is the answer I could go with.
Also, there's also a signed version too. The one for the signed version. If I go back to my screen.
Yeah, Jannar, can you just tell me the problem? Maybe I could just write it out.
Okay. Let me go back to my screen real quick.
Okay.
It says sine parenthesis pi over 12.
All right, sine of pi over 12. Like that, right, Jannar? Sine pi over 12.
Yep.
Okay. So again, I know pi over 12 is not on the unit circle.
So wait, so to do that, then we have to find pi over 12. We have to do like you have to do pi over 12 times 180 over radians.
Yeah, so let's take pi over 12 and you multiply. When you want to change it to degrees, you always multiply by 180 over pi radians.
That's what I did. And then the pi cancels out then.
Yep, pi cancels out.
Then we have to do 180. We have to do 180 divided by 12 then.
Yep.
Okay, so it's like to do this, you could like you have to check like how many times goes 12 goes to 180.
You got it. Good.
Wait, how do you get 15?
Well, if you do 180 divided by 12,
Yep.
you should get the answer 15.
You have to do 15 times 12 to get 180.
Yeah. Jannar, let me show you a little shortcut. If you wanted to work out 180 divided by 12, what if we just simplify this fraction? So how about if I divide the top and the bottom by 2, let's say, to get started? Well, that would be 90 over 6.
Yep.
But I could divide by 2 again.
45 and then 3.
45 divided by 3. 45 divided by 3 is 15.
Yep.
All right, so we're left with sine of 15 degrees. But the bad news is 15 degrees is not on the unit circle.
So what do we do next then?
So we have to try to write this. Let's write this as sine of some number minus another number, where when I do this subtraction, I end up with 15 degrees.
Yep.
Can you think of any two angles that if you subtract them, you'll end up with the answer 15 degrees?
Okay, so like.
And you
So
want
yeah.
those angles to be on the unit circle.
Yeah, so you can do 30 minus, but there's no 15. So I actually do 45 minus 30. To get
You
30.
got it. Good. So I'm going to make the sign of 45 minus 30. Good.
Now we have to use the formula of the signs. Then you have to do sine minus A minus B.
You got it. So now we're going to go and use the sine of A minus B formula. And when I go to look that up, here it is right here, right? Sine of A minus B we'll plug into this formula.
5.
Our alpha is 45 degrees and our beta is 30 degrees.
Now we can use the unit circle for this part right here.
Exactly.
So sine of 45, we say square root 2 over 2. And times cosine 30 will be square root 3 over 2. Minus cosine of 45 will be square root 2 over 2. And times sine 30, which is 1 over 2. Now to do this, you could do left or right, we could do. Now we could do square root of 6 over 4 minus square root of 2 over 4. Then or you could, that could be the answer, or you could do square root of 6 minus square root of 2 over 4, like that.
Okay.
That's what I got.
All right. I think that sounds good.
I mean, I also have tutoring at 2:30, by the way.
Oh, great. Great. Are you using tutor.com?
No, I usually tutor with Josh Masidi.
Oh, okay. Is that
Yeah.
one of the peer tutors at Penn State?
Yeah.
Oh, awesome. And is he doing that like remotely?
Yeah, we usually do online. We usually do it.
Great, great. Are you finding that to be helpful?
Yeah.
Oh, great. Oh, that's awesome. Yeah, that's a good plan.
Yep.
So, all right, great. Let me know if you have any questions then over the weekend.
Okay.
And I'll see you on Monday. Oh, by the way,
Yeah.
Janara, let me just mention